So real quick recap before we go on to the next section. So section 1.1 in our part A recording covered solving simple linear equations with one variable, and that is similar to the homework problems that you'll find 1 through 17 every other odd. And then we moved on to recording B, which had added some parentheses to these equations. So we had to get rid of those parentheses. And that is going to be similar to 21 through 29 every other odd. And then we have one last section of homework when we look at linear equations with one variable using fractions, including fractions. And that is going to be similar to this last section of homework you have. All right, so one technique we can use to deal with fractions is by getting rid of the fractions. So one way to do that is multiply the entire equation by the LCD. That's the least common denominator. And that is the same thing as the LCM of the denominators. So in this case, that's the LCM of 5, 10, and 2. So M, that means multiples. So that means the multiples of 2 are 2 times any integer. So 2 times 1 is 2. 2 times 2 is 4. Then 2 times 3 is 6. 2 times 4. Then 2 times 5. Then 2 times 6. And just goes on with all those evens. And then to find the multiples of 5, start with 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, and go on counting by 5s. And then multiples of 10 starts with 10, counting by 10s, and I get that list. So one way to find the least common multiple of these three integers is by looking at those lists and thinking, okay, where's the first thing that is common? Remember that's least common multiple. So we're looking for the smallest number that is common to all three of these lists of multiples. So I can start with the biggest number because I know the first number on that list is going to be bigger than some of these numbers from the other two lists. And starting with 10, in fact, I can actually see a 10 on the other two lists. So my least common multiple for these numbers equals 10. There's some other ways to get least common multiples too, or these common denominators. I'm going to share a recording that I think for these three numbers, this is probably the easiest way to do that. Another way is to think, okay, when I look at this equation, what can I multiply it by so that all those denominators will end up canceling? That's another way to think about it. And then there's also a way to do it with primes, where you find your prime factorization of each of the values and look for some common primes and the least number of primes that you need. I'm actually going to share a recording from Khan Academy that demonstrates the how of some different ways to find the LCM in the recording below this one. Okay, so we used our list method to find 10 for this one. So I'm going to multiply that whole equation by 10. So 10 times that whole thing, that gives me 10 times 3x over 5 minus 10 times x equals 10 times x over 10 minus 10 times 5 over 2. Make sure every single term gets that 10 gets multiplied, including those the non-fraction terms. All right, so now I can do some canceling. That first fraction, I can see the 5 and the 10 are going to reduce. I can take out a factor of 5 from both of those, and I'm left with that. The second term, I can't do anything with that because there was no fraction, so there's no way to reduce. The next one, my 10s will cancel. They reduce, they both become a 1. And in the last term, I have a 10 over a 2, so I can reduce that. I can take out a factor of 2, and I get 1 in the denominator and 5 in the numerator. Simplifying that, I get 2 times 3 is x. I'm sorry, 2 times 3x, which gives me 6x. 10x didn't change. The next one, I have 1x over 1, which simplifies to just x. And the last term, I have 5 times 5 over 1, which is just 25. Now, this is starting to look like my part A, where I'm going to combine the like terms on both sides. So 6x minus 10x gives me 4x. And on the right side, I don't have any common terms on the same side, so I'll just leave it like that. Now let's get everything with the variable to the left. So I want to subtract x to get it away from the right side, and whatever I do on the right, I got to do on the left. And that gives me 4x minus 1x gives me 3x equals negative 25. And then x, divide both sides by 3, divide that by 3, and divide this by 3 to get x equals negative 25 over 3. And if I take that, and I'm going to take that with a green pen and plug that back into my equation, I see that actually doesn't work out. So I made a mistake, and I wonder if you caught it while you were working along with me. I made a mistake right here. 6x minus 10x should have been a negative 4x, which means when I subtracted x, I would have got negative 5. And then to get x by itself divided by negative 5, I should have got 5. Negative 25 divided by negative 5 gives me 5. So let's try that. Plug that one in, and I get a true equation. So plugging in my 5 up here, I'm going to do that in green actually. So let's plug that on up in green, and I get 3 times 5 over 5 minus 5 equals 5 over 10 minus 5 over 2. So that's 15 over 5 is 3 minus 5 on the left, so I get negative 2 on the left. And on the right, I get 1/2 minus 2.5, which is also 2. Sorry, negative 2. So that is my correct answer. So my solution set would be just the number 5.